Most of us have heard of the law of conservation of linear momentum. It sounds very simple, and the laws go something like this: that the total momentum of the system remains constant, no external forces act on it. But there are two subtle points which students often overlook, and in this video I want to clear them up for you. Let's start with the first one about external forces. Now, when two objects are moving towards each other, say two balls colliding, you might think, wait, isn't friction or air resistance two external forces always acting on the system? Like friction between these two surfaces and here, and air resistance acting opposite to the motion of the ball. And if they do exist, does it mean that the law of conservation of momentum fails over here? Of course not. Here's the key idea. The law of conservation is perfectly valid as long as the external forces are negligible during collision. So when these two balls are about to collide with each other, during that time, the external forces have to be either zero or negligible. So during collisions, external forces like friction or air resistance do exist but should be negligible. And that's what's the case in real life situations. During collision, these forces are negligible. And what's the reason for that? The reason for that is because the collision themselves happen in an extremely short span of time, often just few milliseconds. And in that tiny fraction of second, the forces between the colliding objects, that is the internal forces, are much, much stronger than the external forces like friction or air traffic. So practically we ignore these forces, and that's why in real experiments like billiard ball or car crashes or particle collision, momentum is conserved during the collision. Now for the second subtle point, which is almost never stressed, that is about when to measure momentum. Now, when we say initial momentum, we mean the momentum just before the collision. And when we say final momentum, we mean immediately after the collision. Not a second later, not a millisecond later, literally within nanoseconds. What's the reason? Because after the collision, if you breathe, forces like friction or gravity will come into play, and then they will change the momentum of the system. That's why in physics, we freeze the timeline just before the collision and immediately after the collision. So these were the 2 points that I wanted to stress upon for understanding conservation of momentum very well. Let's summarize. Point number one, external forces must be negligible or non-existent during collision. Only in that case, the law is valid. And secondly, the momentum conservation applies only just before the collision and just after the collision. And if you keep these 2 points in mind, you will never be confused again with law of conservation of linear momentum.